Hello friends, welcome to Math Opera. Myself Salil Gadge. In this video, I am going to explain how to construct a triangle provided its perimeter is given and the base angles are given. Not just that, but I am also going to explain the rationale behind this construction. So let's see how it's done. So in this segment, I am going to show you how to construct a triangle provided its perimeter is given and the base angles are given. So now before we construct it, let's understand the rationale behind it. The problem statement says construct a triangle ABC where angle B is 60, angle A is 80 and the perimeter, that is sum of the sides, is 12 centimeters. So I have drawn a rough figure here. This is what I actually want to construct. The points are A, B and C. Angle A is 80 degrees, angle B is 60 degrees. The measurement of this segment would be AB, this would be AC and this would be BC. The challenge here is we do not know where these points actually are because we are not given the individual measurements, we are given the perimeter of the triangle. So let's assume that the triangle is going to look like this. The goal is to find these 3 points. Once you figure out these 3 points, it's going to be easy to construct this particular triangle. So what I have now done here is, I am extending the segment BA on the left side such that the length, it is extended till a point X such that AX is equal to AC. Okay, I am extending it in such a way that AXA is equal to AC. Similarly, AB is being extended towards the right side till a point Y such that BY is equal to BC. Alright. Now can you tell me what is XY, the length XY? XY is going to be AC plus AB plus BC, which is actually 12 centimeters as given in the problem. So this we know, so I can definitely draw a line segment XY of length 12 centimeters and this length XY is going to comprise of segment AC, segment AB and segment BC. We still don't know where the points A and B are, but we know that A and B lie somewhere on this particular line segment. Now what I am going to do is, we are going to use these two properties. The first property is diagonals of a rhombus bisect the vertex angle. This is a very well known property of a rhombus. And the second property is diagonals of rhombus bisect at right angle. So we are going to make use of these two properties over here to construct this triangle. If I draw a line or if I draw a 80-degree angle at X, so I know that one of the base angles is 80 degrees. So if I draw a 80-degree angle at X and say I draw a line parallel to AX over here, what is the figure that I am getting? Since I have drawn this as 80 degrees, I know that these two lines are parallel because their corresponding angles are equal. Similarly, I have drawn these two lines parallel. So this is a parallelogram for sure. The opposite sides are parallel. Two pairs of opposite sides are parallel. Moreover, one pair of the adjacent sides is equal. That means this particular figure is a rhombus. I also know that the diagonals of the rhombus bisect the vertex angle, meaning now if I bisect this particular 80 degree, I am going to get the point, or it is going to form one diagonal of this particular rhombus. So if I bisect the angle 80 degree, I am going to get XC. Similarly, over here as well, if I draw a 60-degree angle from Y, so I am drawing it with a rough hand. So if I draw a 60-degree angle here, we know that BC is going to be parallel to this segment, as well as CZ. Let's mark this particular point as Z. So CZ is parallel to BY. This again is a parallelogram because two opposite pairs of sides are parallel and one pair of adjacent sides are equal. So BC is equal to BC. Therefore this figure is also a rhombus. So if I bisect angle Y, then I should be getting one diagonal of the rhombus. So what this really means is, I can draw the complete XY segment because I know that it corresponds to the perimeter of the triangle. So I'll get 12 centimeters, XY is 12 centimeters. From there I can actually draw half of the angles, half of 80 degrees and half of 60 degrees. The two rays or the two angle bisectors would actually help me locate this particular point C. So I have been successful in locating point C so far by drawing the angle bisectors of angle A and angle B from the points X and Y respectively. So I draw these angle bisectors. So I am marking the steps of the construction using these arced or these curves. Okay. So I first draw XY, which is the perimeter of the triangle. I draw the angle bisectors from X and Y, angle bisector of A from X and angle bisector of B from Y to locate the point C. Now I know that XC forms one diagonal of my rhombus, correct? So XACW is a rhombus in which I have marked one diagonal. If I draw the perpendicular bisector of the diagonal XC, then I should be able to locate the other diagonal because of the property shown here. The diagonals of the rhombus bisect at right angles. So XC being one diagonal, if I draw the perpendicular bisector of that diagonal, I am going to get the second diagonal, which is WA, and that helps me in locating the vertex A. So after I draw XC, I draw the perpendicular bisector of XC, and wherever it intersects XY, that is point A. Similarly, if I draw the perpendicular bisector of YC, then it is going to help me locate the second diagonal, which happens to be BZ, correct? And this BZ helps me locate the point B. So I have located point A, I have located point B, and I have located point C. So quickly, as a quick recap, I draw the base, which is equal to perimeter of the triangle. I draw half the angles from X and Y, half of angle A from X, half of angle B from Y. That helps me locate C. I join XC and I draw the perpendicular bisector of XC. That helps me locate point A. I draw the perpendicular bisector of YC and that helps me locate point B. I get my required triangle ABC. So the concepts used in this construction were diagonals of a rhombus bisect vertex angle and diagonals of a rhombus bisect at 90 degrees. Now let's get to the construction part. Done. So in the previous segment, we understood the rationale behind this construction. Now let's actually construct this triangle. So the problem statement is construct triangle ABC where the base angles are 60 degree and 80 degree and the perimeter is 12 centimeters. I have constructed a line segment XY of 12 units. So in my case, since I am drawing it on the whiteboard, I have taken a bigger line. On your notebook, you can actually take a measurement of 12 centimeters. Then from X, we have to draw the half of angle A, which is what we saw earlier. So half of angle A is going to be 40 degrees. So using my protractor from the point X, I take a measurement of 40 degrees, which is the point that I have marked over here. So after I take 40 degree, I join that particular point with X. So that would be the angle bisector of the vertex angle of the rhombus, which we saw in the earlier section. So I have drawn a 40 degree angle here. Now from the point Y, I should draw half of angle 60 degrees, which is 30 degrees. So from the point Y, take an angle measurement of 30 degrees. So I have already done that and join those 2 points, Y and the 30 degree marking. So now we saw earlier that the intersection of these two angle bisectors actually gives us the point C. So we have already got our point C. So how do we get the points A and B? We should draw the angle bisectors of XC and YC. Sorry, we should draw the perpendicular bisectors, pardon me. We should draw the perpendicular bisectors of XC and YC. Once you draw the perpendicular bisectors of XC, you are going to get that second diagonal. Do you remember? You are going to get the second diagonal of the rhombus, and wherever that perpendicular bisector intersects XY, that would be point A. So now let us draw the perpendicular bisector of the segment AC. So place your rounder on X, take more than half the measurement of XC and draw an arc. Similarly, with the same measurement, keep the rounder on C, more than half of the same measurement, draw an arc. Since the two arcs don't intersect, I should actually extend the first arc. So I've got one point where these two arcs intersect. Now similarly, draw an arc on the other side, preferably with the same measurement. So I have drawn an arc over here from X with the same measurement. Draw an arc from C. So again, if the two arcs don't intersect, you will have to extend those arcs so that they intersect. So since the two arcs are not intersecting, I'll keep my rounder again at X and I would extend this particular arc. Yes. So now we have these two arcs intersecting, and if I join these two, the arc which is above the line XC, line segment XC, and the arcs below the line XC, the point of, if I join those 2 points, I am going to get the perpendicular bisector of XC, and the point where it intersects line segment XY, I would label that point as A. So this particular point is my point A. Similarly, I should now draw the perpendicular bisector of YC. So again, with the same procedure, take more than half the measurement of YC, place your rounder on Y, draw an arc above as well as an arc below. Your measurement should be more than half of the measurement of the line segment, otherwise the two arcs will not meet. That's why there's a requirement that the measurement should be more than half the measurement of the line segment. Again, draw arcs. You will notice that on the upper side the arcs are not intersecting, which means that I will have to redraw the arc from the first point. So I have redrawn it here. So now again we have these two arcs intersecting, and if I join these points, I get the perpendicular bisector of YC. So if I draw this perpendicular bisector, it is going to intersect this particular point at B. So this is my point B. Now I have point C, I have point A, and I have point B. I should just be joining the points C and A as well as C and B, and this particular triangle, the triangle which I am shading, is the triangle that we need. Now you can verify whether this is really the triangle that you wanted. What you can do is you can measure this particular angle A, you can measure angle B, you can add up all the sides of this triangle and check whether you are getting 12 centimeters as your sum of all sides. So if you are getting all these measurements perfectly right, it means that your construction is exactly accurate, and I hope that this clears up how to construct this particular triangle where the base angles are given and the perimeter is given. So I do hope that after watching this video, geometry makes more sense to you. Do like, share and subscribe my video channel and stay connected for more updates. Let's learn mathematics. Let's enjoy mathematics. Goodbye.